Usually the average is a better indicator for a sample subgroup than the median, but today's median chart has such a big advantage. Really, you will want to use it in your production. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. Today's video is about the median chart. And at first glance, a median chart looks a lot like our standard control charts. And in fact, if you take the basic literature on the median chart, you will see that it uses the same configuration as a control chart. It has the same constants also, so you have your D2 and you have your A2 to calculate what the control limit should be. And you even interpret a median chart in the same way if you use the median control chart. I will also go into a slightly different version of the median chart that, well, it blew my mind when someone actually from the Dutch Metrology Institute, so basically the guys here in Holland who are responsible for checking meters and gauges and really making sure that we are using measurement and statistics to trade in a fair way. They told me about this one. Of course, it is an ideal tool if you want to do it on paper, and that's what we'll get into. Because I will say, usually when you take a subgroup for sampling, you have a couple of products that are rolling off the conveyor just one after another, and when you want to say something about it, the normal statistic, descriptive statistic that you use will be the average. You just pick them up, weigh all of them, combine it, divide it by the number, and then you get the average of that subgroup. And that is a good measure. Let's say if you have four that are almost the same and one is a little bit higher, it pulls up the average a little bit, but not by a full one. Now the median, that is, if you put them on a row from low to high, you always pick the middle one. So if you, by some chance, let's say, and we'll take a bit of an extreme example here, but if you would take 1, 1, 1, 2, 2, then the median is the third in this order. It's always 1, 1.0. While if you would take the average, and okay, 7 divided by 5, that will be 1 point. Now my mental calculations go a bit awry, but 1.3. So it's in-betweenish. A median will never give you an in-betweenish value. So you could say, well, it's wrong. But it has a great benefit. Now for that, we'll have to explain the chart. And this one I drew here just to, and we'll get back to it a little bit later, but just to know there is a median control chart as well. It looks, before we put in any numbers, exactly the same as our normal average of a subgroup or even individual measurement. So you have your IR chart, so the individual and range chart, or what we often call the X bar chart, which is X bar basically means the average, so an average of a subgroup, and you put it here. Now, this you can also do with a median. Slightly different story. We'll look at a specific case, and this is the one we'll be implementing now also in my own factory, and that is more about the weight. And the weight here cannot go below a threshold. In fact, to explain this chart, the weight should be at 150, which also for us means that the average weight should be at least 150. But a single package, or even a couple of packages, they are allowed to go under 150 as long as it's not too far, as long as it's not less than 148, and as long as over a time span you keep over this norm average. Our time span, by the way, for this would be each hour it's needed. So for that, well, you check a bit how much time do you put in between all of your measurements. But let's say that we pick 15 minutes. We'll get back to that in a bit. How do we fill it in? And this is where the magic happens. We are going to say every sample, so one measurement, has a sample subgroup of 7 products from our production. So at time 0, basically startup of the line, or better to say, just after your operator has fully set up the line, they've been testing a bit, and now they say, okay, we are ready for regular production, because many lines have a slightly lower or higher weight completely at the start of a setup, but the setup's done, we're ready for normal production, we're running, and we're taking 7 samples. Now my first sample was 152 grams, so I just note that down. Then my second sample, it was a little bit heavier, 153, and like this I take 7 samples. Now in the end, and the order in which I got them, that doesn't really matter. I got 1 sample of 151, 4 samples of 152 grams, and 2 samples of 153. Now if I put them in order, so from low to high, when we have 7 samples, the median will be number 4. So we count from 1 of either side, we count 1, 2, 3, 4. The median is in this square, which means that the median in our case is 152. Now for this graph, and let me first, this is pretty easy to calculate, right? If I would have to calculate the average, you will see that the average will be very close to 152. There's 1 that's lower and 2 that's higher. So we need to add 1/7, so that's 0.14 to this. So then the average would be somewhere here, 152.14. For the median, we just have this. Now the other thing we did when constructing this chart is that this assumes that you have scales, measuring weight in my example, and that you have scales that have a measurement interval of 1 whole gram. So I made a raster that has grids for every single gram. Now if I would have put there scales that have a measuring interval of 5 grams, it's a bit useless. I don't know what to do with all the underlying, all the in-between squares. The other way, but it would at least be relatively easy to fill in. The other way, if I put scales there with 0.5, so half a gram of accuracy, then at some point we'll get a measurement saying 152.5. Where do you put it? You cannot, well, you can put it here in the middle, but that doesn't work. So we also, by design, link the grid size to the measurement accuracy, to what our display on the scales is giving us. That means that basically what we're doing here, it doesn't require a calculator. I mean, you've been watching me fumble my calculations already a bit. Maybe a couple of you in my previous calculation, no, but that's 0.4, and that's the whole thing. You don't want all the operators in your factory having to calculate the whole time. You don't actually even want to put a calculator next to it, because it just makes life harder, and that is not what you need next to the line. Now, the other thing you can see is, oh, it's a bit on the high side. We can put some control limits in here. One measurement, so to say, to me is never a measurement, but what you'll probably see is that the operator will correct the line a little bit. Then after 15 minutes, remember we wanted to do 4 checks an hour in this one, so the hour will be in that column at the end. After 15 minutes we check again, so again we take 7 samples of the conveyor and simply note down which weights we got. Now apparently we got a little more spread, but we'll do the same again. 1, 2, 3, 4, this one here. So now our median weight is 151. We dropped 1 gram. By now, nothing's wrong yet, by the way, it's all over 150, although maybe we're giving away a little bit too much. But by now the operator will probably start to react and say, well, okay, it's a bit high, let's really adjust and get it down 1 more gram, right? So after again 15 minutes, we end up under the line, because 1, 2, 3, 4, the median is over there. Even though the average would almost be at 150, we see the median going down. Now again, remember, we have an hour during which it is allowed to be sort of averaged out over it, and as long as nothing hits, no median hits the lower border, it's okay. So basically our operator should not react too much, but what we do need is the next one to again be over. This is the way that you control your process, and after, well, basically after 45 minutes and then after an hour, and we'll check that one as well. We have 1, 2, 3, 4. 1, 2, 3, 4. So what we see now in our first hour, because the hour is actually in between these columns every time, is that on average we are definitely over the line, nothing dropped out, and I did not need a calculator at all. The other nice thing is that actually hidden in here I have a whole bunch of individual samples, because the operator just dotted them all down. So if I really want to, from time to time, get a good grip on how machines are performing and how the products are coming out and is my weight stable, I can go in. I don't need to, but I also don't want the operator to really calculate the range from this, because that again, it's calculations and it's more plotting and you need to do something with the range. But if I'm in my continuous improvement mode and just want to pick a product that has my interest, from time to time I can go and collect these data sheets for 1 or 2 weeks of production of a specific product and really go and check them and say, oh well, apparently we have a lot of data. We can calculate standard deviations, we can calculate how stable is our device, and you can actually see, because this is not a control chart, but from this data we can make also a control chart if we want, or we can do all kinds of calculations. We can see things like, is there a certain seasonality, or do we see startup stuff, or do we see the spread, the range in our samples widening. So a lot of data is preserved in this chart. That is not preserved if you do a calculation and only write down the answer. But on the other hand, no calculations were needed, and this gives you very nice control. Now, this is the pen and paper version of what I also saw. That's the chart I knew before we had this very nice and useful audit. A couple of videos ago I talked about, are audits useful and do they really bring something to your organization? Well, I must admit, we had an audit about our measuring system, and it's basically a regular check on if we weigh our products correctly and what we can do to improve it. And they actually even helped us to get a bit closer to the norm by saying, well, that line may look like you cannot really control it as easily as one with an automated weighing installation, but hey, here is a pen and paper system. So thanks for that. The one I knew before that, I think, is not as useful. See, if you make a median control chart, what you also do with basically the same here is what you do there is you plot them, and then you draw the lines, and then you check with the lines, are they going to fall outside of my control limits? Are they going to do the normal sort of SPC rules? Do we have 2 out of 3 over 2 sigmas? Are we seeing everything on one side? But this here is already, well, you saw it took me longer, and then I had to draw lines, and then I don't know, it just isn't as easy to fill in. And if I'm going to take the trouble of doing all of this anyway and making a chart that makes it, in my opinion, less visible, so less visual and not as clear as this one, then, you know, just take that calculator or just put it into an electronic system. And as soon as you do that, why don't you just take the average and take a normal average next bar control chart? So for that, I never really liked it so much. But this here, well, I became a fan. So that's the one I wanted to give you today. And it's a one topic video, but that's a good thing, right? Use a median chart where you can have the squares, the raster, be the same as your unit of measurement, or actually it has to be exactly as precise, as detailed as the display or whatever your operator is getting, so that they can simply copy all the marks that they get, and they know they should take the middle number. So in my subgroups of 7, you always take number 4. And then at some point, when this system is working, you can even afterwards start putting in the needed control lines. Because as soon as we get enough of this data, well, then we can put in some upper control limit for steering the process. We can also start doing a little bit more on the down end, on the lower end of this graph, but don't overcomplicate it. That's the message. This is pen and paper next to the line, direct control. So this really is a control chart, not a nice statistic thing to give to your auditors afterwards, or to make, you know, material efficiency calculations or things like that. This is for the operator to know when they need to turn a dial on the machine, or even when they need to stop production because you have had a quality issue. Because in the end, if you don't put the required amount of weight into your product, you've got a quality issue as well. So that makes it a very strong tool and easy to implement. And that's what we'll be doing over the coming weeks. So I hope this also inspired you. Maybe you knew already the median control chart, but this one, if you are not familiar with it, well, to me it was an eye-opener. I hope you liked it as well. If you do, don't forget to hit that like button. And also, if you have such useful practical tools, let me know so that I can let the rest of you know. It's really useful stuff to be sharing, especially also in this digital age, which tools are very easy to do with pen and paper. For now, I wish you the best of luck in your continuous improvement journey. And as always, don't forget to enjoy that journey.